Let's take a look at example 6, which is very similar. So taking a look at example 6, it says evaluate the limit as x approaches 0 for 2 minus the square root of 4 plus x all over x. Again, I always double check to make sure that if I do direct substitution, if it gives me indeterminate form, then I'm going to have to change it. If it doesn't, then you already get your limit right away. So in this case, again, I'm going to do the limit as x approaches 0 for 2 minus the square root of 4 plus x all over x. So I'm going to do a direct substitution in here. I'm going to get 2 minus the square root of 4 minus 0 over 0. If you simplify, you actually get an indeterminate form. So that means we got to do some work here. So let's think about it again. This looks similar to example 5. I've got some radicals, which means I'm going to have to rationalize. And more specifically, I'm going to have to rationalize my numerator because my radicals are in my numerator. So I'm going to start off my question. I'm going to do the limit as x approaches 0 for 2 minus the square root of 4 plus x all over x. So I'm going to multiply by the conjugate of my numerator. So that's going to look like the following instead now. So the conjugate that I'm multiplying the top and the bottom by, I don't know why I keep on writing 0. That should be x. My apologies, guys. So I'm going to multiply by the conjugate, which is going to be 2 plus the square root of 4 plus x, all over 2 plus the square root of 4 plus x. We're going to simplify the numerator and the denominator now. So in this case, I've got the limit as x approaches 0. I'm going to get 2 squared minus 4 plus x. Remember, the square root and the square, they end up canceling out, which is why I'm left with 4 plus x. Remember to have the brackets around there because the minus sign is going to change all the signs there. All over x times 2 plus the square root of 4 plus x. We're just going to make it look a little bit cleaner now. So I'm going to do the limit as x approaches 0. And if I clean it up, what I have at the top there, I'm going to get negative x all over x times 2 plus the square root of 4 plus x. At this stage, you notice, hey, I can cancel out the x and the x. And then I'm left with the limit as x approaches 0 for negative 1 all over 2 plus the square root of 4 plus x. At this stage, after simplifying, you notice that if you did a direct substitution of plugging x for 0, you should have no problems, which means that I can do a direct substitution now. So I'm going to do negative 1 over 2 plus the square root of 4 plus 0. And if I simplify that, I'm going to end up getting negative 1/4. So for example 5 and 6, we used rationalization. More specifically, we rationalized the numerator. Sometimes you'll have to rationalize the denominator. You just have to notice where the radical is at the very beginning and then go from there. All right, let's take a look at example 7 because I'm sure that looks very different now. All right, for example 7, what you notice here, it says it asks you to evaluate the limit as x approaches 0 for x plus 8 all to the exponent 1/3 minus 2 all over x. Now, in many cases, this is the first time that you've seen a fractional exponent, and that's going to cause us a problem, but don't worry, we're going to get through this. So we'll start off again by doing a direct substitution, just to make sure that, if we don't get indeterminate form, then we can avoid all the stuff that we need to do. So what I'm going to do is I'm going to say the limit as x approaches 0 for x plus 8 to the exponent 1/3 minus 2 over x. In this case, I'm going to do a direct substitution, like I said. So I'm going to do 0 plus 8 to the exponent 1/3 minus 2 all over 0. This results in 0 over 0 for us, which means we have an indeterminate form. So how are we going to tackle this particular limit now? So I'm going to write out my limit first. And I know what comes to mind first is, well, miss, it looks like something that we could have factored, but I don't know how to factor with fractional exponents. So how are we going to approach this question? We're going to use something called the change of variable. So you're going to listen very carefully. So notice here that you've got something in the numerator that involves x, and then you have something in the denominator that also involves x as well. So I'm going to look at the x with the lowest exponent, if that makes sense. At the top, you have 1/3. At the bottom, you have 1. So I'm looking at the top to help me. So I'm going to look at this portion here. Okay, so I'm going to look at x plus 8 to the exponent 1/3. And what we're going to do is we're going to use that to help us here now. So for x plus 8 to the exponent 1/3, I'm going to say I'm going to use a variable to represent that. So you could use W, V, Z, A, B, C. It's totally up to you. I generally say try not to use x again because you already have x in your limit, right? So I'm going to use the variable u. So I'm going to say let x plus 8 to the exponent 1/3 equal to u. And now we have to talk about this now. So my limit talks about x approaching 0. So if my x is approaching 0, if you were to plug 0 in for x plus 8 to the exponent 1/3, what number is your u going to be approaching then? So if you plugged 0 in for x, if you did 0 plus 8 to the exponent 1/3, that's going to be 2, right? So u is approaching 2. So whenever you do a change of variable, you have to make sure that you also talk about what that variable is approaching. So I've got x plus 8 to the exponent 1/3 equaling to u. And I've also stated that as x is approaching 0, my u is approaching 2. But wait, in my denominator, I also have x. So now I need to change x so that it's in terms of u now. So here's the tricky part. You need to use what you created first to be able to get down to x. So if I take a look at x plus 8 to the exponent 1/3, and I know that it equals to u, your job is to isolate for x here. The first thing that comes to mind is we're probably going to be raising both sides to the exponent 3. So I'm going to do exactly that. And then I'm going to be left with x plus 8 equals to u cubed. Then I notice, I can move the 8 to the other side now, so I can get x on its own. So I'm going to have x equals to u cubed minus 8. And what we've done here now is I've turned x in terms of u now. So I have everything in terms of u, and that's going to come very, very handy for us. So, like I said, we did that substitution there with x plus 8 to the exponent 1/3. And at the same time, we also got x in terms of u as well. So now what we're going to do is we're going to rewrite our limit. But rather than keeping it in terms of x, we're going to use our new variable, which is u. So I'm going to do equals the limit. And rather than dealing with x approaches 0, I'm dealing with u approaches 2. And then instead of x plus 8 to the exponent 1/3, I'm doing u. The minus 2 stays, and then all over. Rather than x, I'm doing u cubed minus 8. That's what we're talking about doing a change of variable or substituting a variable in. The new limit that we have there in terms of u is a much more approachable limit than what we had originally. So now when I take a look at it, it's still, if I do direct substitution, it's still going to be an indeterminate form. So I recognize, I could factor this actually. Okay, you have a differences of cubes at the bottom there. So we're going to factor it. So I'm going to do the limit as u approaches 2, and then I've got u minus 2 at the top. At the bottom, if you factor this for differences of cubes, you're going to get u minus 2, and then you're going to get u squared plus 2u plus 4. Right away you notice, I can cancel out the u minus 2. And then I'm left with the limit as u approaches 2 for 1 over u squared plus 2u plus 4. At this stage, if you did a direct substitution for u equals to 2, it's not going to cause you any problems. So we're going to do exactly that. I'm going to do 2 squared plus 2 times 2 plus 4, which is then going to leave me with 1 over 12. And so the limit as x approaches 0 for x plus 8 to the exponent 1/3 minus 2 all over x is 1 over 12. To solve this particular limit, you had to do a change of variable. Because of those rational exponents, that fractional exponent, we didn't like it. So we had to do a change of variables, so it was a lot nicer for us to work with. And when we solve our limit, you don't have to worry about changing anything back in terms of x. Since we've taken care of what it will approach and we've turned everything in terms of u, that's why we can solve the limit in terms of that variable u instead. Let's take a look at example 8. So for this one, it says evaluate the limit as x approaches 1 for x to the exponent 1/6 minus 1 all over x minus 1. Again, we notice there's a fractional exponent, which means we may have to use the change of variable like we did in example 7, but we don't know. Let's try out direct substitution first, and if we get an indeterminate form, then we'll think about it. So if I do this, I'm going to do the limit as x approaches 1 for x to the exponent 1/6 over 1 all over x minus 1. So if I do direct substitution, this is what you're going to get. And if you simplify, you end up getting 0 over 0. So it did give me an indeterminate form. So now I need to think about, okay, let's do a change of variable here because I see that fractional exponent. So I'm going to write down my limit first. The limit as x approaches 1 for x to the exponent 1/6 minus 1 all over x minus 1. So in this particular case, I'm going to focus on x to the exponent 1/6. Remember, I said if you notice that there's a fractional exponent, look for the one that has the smallest exponent. In other words, between 1/6 and 1, 1/6 is the smallest one. So I'm going to do a change of variable for x to the exponent 1/6. I don't include the -1 because it's not part of that exponent there. So if I take a look, I've got x to the exponent 1/6, and I'm letting that equal to u. Again, once I do that change of variable, I need to talk about what we're approaching then. So I know that in my original question, my x was approaching 1. So if I'm using my change of variable equation here, if my x is approaching 1, if I plugged 1 in here, that indicates that my u would also be approaching 1 as well. So that deals with that first portion. But you can't have two different variables in your limit. So now we've got to deal with x, which is at the bottom now. Okay, we got to deal with x. So if I take a look here, remember we have to go from x to the exponent 1/6 equals to u, and we have to use that to help us get to x. So if I take a look at that, I've got x to the exponent 1/6 equal to u. How can I get the left-hand side so that it's just equal to x? The first thing that comes to mind is to raise both sides to the exponent 6. So that's exactly what I'm going to do here. And when I do that, I'm left with x equals to u to the exponent 6. So what I was able to do here was to rewrite my variable x in terms of my variable u. So now that I have my change of variable completed on the side, I'm going to rewrite my limit now. So I'm going to do equals the limit, and then we're no longer dealing with x approaching 1. We're dealing with u approaching 1. And instead of x to the exponent 6, we're dealing with u and then minus 1 all over. Rather than dealing with x, we're dealing with u to the exponent 6 and then minus 1. And so that becomes the new limit that we're going to take a look at solving. So right off the bat, you notice, I probably need to factor here. Now, chances are you're going to either be undecided on whether or not you want to do a differences of cubes factoring here or a differences of squares. Always do the differences of squares factoring first. If you have to choose between the two, I'm going to write it here. Do differences of squares first. If you don't, you're going to be left with something that you don't necessarily know how to factor. So just keep that in mind. So do the differences of squares factoring first. So if I do that, I'm going to be left with the following. I'm going to have the limit as u approaches 1, and then u minus 1 all over. This is going to give me u cubed minus 1, and then u cubed plus 1. So right away, what I notice here is that I've got a differences of cubes, and then I've got a sum of cubes. Now, depending on what you see here, you're going to notice that you may not have to factor everything out. So the one that I'm highlighting, you're going to see, I'm not going to factor u cubed plus 3. I'm not going to do that. And the reasoning for that is because if I was to factor that, I get u plus 1. And that's not going to help cancel out u minus 1. So I'm going to keep u cubed plus 1 on its own. I am going to factor u cubed minus 1 though, because I know that that's going to bring me out u minus 1. So let's do exactly that. Hopefully I'll have enough space. So I'm going to do the limit as u approaches 1, and then I'm going to do u minus 1. I'm going to keep u minus 1 here, and then I'm going to be left with u plus 1, and then u cubed plus 1 at the end. By doing that, like I said, this is the smart factoring, right? You're not factoring everything. You're factoring what will be useful for you. So in this case, u plus 1 and u plus 1, they can disappear. I realize I ran out of space for this question, so I'm going to do it up here. Then I'm left with the limit as u approaches 1 for 1 over u squared plus u plus 1 times u cubed plus 1. At this stage, after simplifying, I realize if I do a direct substitution for u equals to 1, it's not going to cause me any problems. So I'm going to do exactly that now. So that's going to give me 1 over 1 squared plus 1, all in brackets, times 1 cubed plus 1. If you simplify this, you're going to end up getting 1 over 6. So the limit as x approaches 1 for x to the exponent 1/6 minus 1 all over x minus 1 is equal to 1/6. But we had to do a change of variable here because we didn't want to work with those fractional exponents.